This is the third video in talking about problems in test of proportion. So let's get right to that. Looking at problem number 3. Again, what we're doing here is primarily we're identifying how we can use the calculator to help us do some of this stuff here. And in particular, we'll demonstrate how we can use the calculator to help us find critical values and how we can use the calculator to help us find p-values, and then how we can use the calculator to help us answer, basically replace step 2 test statistic and step 3 finding a p-value using a test on the calculator. So here's the problem. An ornithologist publishes in a journal that proportion of the population of finches that have orange beaks is 37%. A rival ornithologist randomly samples the finch population and finds that 59 of the 200 finches he observes have orange beaks. Using a 0.05 significance level to test the claim that the proportion of finches that have orange beaks is less than 37%. I've highlighted claim information in yellow, and you need to make sure that you can distinguish between claim information and sample information. I've highlighted the sample information in blue or turquoise here. So we've got the information we need with the claim information. We've got the information we need, and that is that the proportion is less than 37%. 37% basically screams proportion. So we know we're dealing with p as a parameter, and the value is 0.37, and less than is a relationship. So the claim is p less than 0.37. We're also given alpha here. I didn't highlight that part right there. So we got alpha, and we got the claim. We can find the null and the alternate. I'll leave that up to you because we covered those pretty well in the 8.2 videos. Then we have the test statistic. We know since this is proportion, we're dealing with the z. We need to know what p hat is and n. Well, we have n, and 59 over 200, x over n is p hat, so we calculate that. Substitute the assumed value from the null hypothesis, which is 0.37 here. Q is going to be 1 minus that. And all of that in there, we calculate negative 2.20 as our test statistic. So the next question is that an unlikely value based on the assumption? Well, we can do that 2 ways. One is with the critical value, and we could go to the table with that to find that. But what we're going to do instead is use the inverse norm function, and remember from previous problems that it's second vars 3, and we need to put in the less than probability. This is a left-tailed test from H1. It says less than, so that's a left-tailed test, which means the area underneath the curve farther away from the mean on the left is going to be alpha, all of alpha, so it's going to be 0.05 in this case. So let's take a quick journey to our calculator. And we're going to go second vars number 3 to get the inverse norm. 0.05 is the area underneath the curve to the left of that critical value. And we hit enter, and we get negative 1.645. Okay. So basically remember that inverse norm, where to go find it, second vars number 3. And we need to know that the number you put in here is a less than probability, the area to the left of the critical value that you're looking for. Okay, so let's exit out of here and go back to our problem. And if we were to plot that, once we have a critical value and we know what the test statistic was from step 2, we can plot this horizontal line for z's and then our curve, and we plot the critical value, which is negative 1.645, and then we plot the test statistic as well, which is negative 2.2, and we determine if it is farther from the mean than the critical value on that side. And it is in this case. Negative 2.2 is less than negative 1.645. So that tells us what our, we take that into the wording of our decision. Let's look at the p-value now. And remember that what the p-value is, it's basically the area underneath the curve farther from the mean than the test statistic. So wherever the test statistic in this case is on the left, so we're finding an area underneath the curve to the left, which means the boundaries are from negative infinity up to the test statistic. So we're going to put those two into our normal CDF function, because what we're looking for is the p-value is a probability. So let's go find that probability and share this. And let's clear that. And inverse norm, normal CDF is second vars, it's number 2. And now we need to put in the lower bound, which is way off to negative infinity. So negative 9999 is what I typically use, comma, and then the upper bound. And remember that area ends at the test statistic. So negative 2.20. Close the parenthesis and hit enter. And there's our p-value, 0.0139. Okay, 0.0139. So let's get out of here and go back to our problem. What do we do with the p-value? Our p-value is 0.0139. Well, we have to compare that to alpha. That's the rule, and the rule is for rejecting, we'll reject 80 if the p-value is less than or equal to 0.0139. That's a little fact that you need to get into your head and permanently. And so once we have our critical value and we know where the test statistic is relative to that, so we know that we're probably going to reject, and we know that our p-value is less than 0.05, so we know we're going to reject because of that. And we state our conclusion, or state our decision, reject 80 because p-value is less than alpha, and or because the test statistic is farther to the left of the left critical value. Negative 2.20 is less than negative 1.645. And then we make our decision. And then remember what we're doing here. This basically, the one prop Z test is a test of proportion, but it's not the whole test. All it does is provide us an answer to step 2, what is the test statistic, and an answer to step 3, what is, in this case, what is the p-value? No critical value approach used when we use a calculator test. We need to know what information goes in. We were given a value of X and we were given a value of N, so we're good there. We know what the assumed value is, 0.37. So let's go run that on a test statistic or on the calculator. And we get, yes, let's clear that. And where do we find one prop Z test? Stat, tests, and the one prop Z test is number 5. So I'm going to type in number 5. If you just remember that it is number 5 for test of proportion. And 0.37 was it? Yes, 0.37. Oops. All right, 0.37. And 59. and 200. And it was a left-tailed test. So let's go down to here and over to P, to less than, hit enter, and then we go down to calculate. Hit enter, and we get a test statistic value of negative 2.197 to 3 decimal places, or negative 2.1 or 2.20, sorry, and which is what we had from before. P-value 0.0140. I think that's slightly off from what we had, that what we calculated, but we can double check that. But it's if not the same, it's very close, and it would give us the same result. But these two answer, this is the result of step 2. This is a result of step 3. Okay, so let's get out of here. And there are 2 little problems that we're going to discuss briefly in a short video after this. So let's go ahead.